In question 1 on the exam, we were given the starting point of the formal fugacity relationship for vapor-liquid equilibrium. And what we wanted to do was explain the simplifications and assumptions that would be needed to get us to the point where we could use the simplified Raoult's law and Henry's law to describe a binary mixture. And so really the key here is what are the explanations and looking at each item in the full fugacity relationship item by item to see what has to happen. And the first thing is that if you look at the gas side for both components, what happens is the exponential term disappears. Now the exponential term is looking at the integral of the vapor volume minus RT over P. And what we'd really like is for that to become a quantity of 1, and so exponential of 0 has a quantity of 1. And so what we're saying is that these two pieces are the same. So we are saying that we are assuming it is an ideal gas, which means that usually it's not going to be an exact ideal gas, but it's ideal gas-like, which means that low pressure is an indicator that it would be close to being an ideal gas. That component will go to 1. If we look on the liquid side, again, we have a similar sort of thing that this piece doesn't seem to appear in either one of our expressions. And so we need somehow that our pressure, if we're saying low pressure, it's going to be a low pressure for the entire system. And typically that means that we're going to have that exponential piece again go to 1. So that's going to also make this piece go to 1. And so we have gotten rid of the two exponentials through a low pressure assumption. Now, we need to get rid of the gamma. Let's focus on component 1 first. What I know about gamma, I would like that to go to 1. And when that happens is when I am nearly pure. So I am assuming that X for component 1 is nearly 1. And so that has equation 1 finished for me. For component 2, well, my gas side is okay, but I need to explain where this H comes in. And H is simply a definition. Okay, so this one actually was the easy part because all you need to do is say, well, you define it in such a way that it's going to encompass the gamma for component 2 and the vapor pressure for component 2. And this is going to be true only when X for component 2 is very small. And so this is a definition that we use. Thank you very much for your time.